Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. This is Dr. Elena Hyde, and I'm joined tonight by Julie Tomei. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, but not in a way that you have heard before. This York Universe is in fact airing directly onto YouTube. That's right, we are not on astronomy.fm, although we will be sending this broadcast to them. We are in fact directly live on YouTube for York University tonight. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at about 2 a.m. UT or EST, I think. So, depending on your time zone. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs at this exact same time. So, this particular broadcast being live on YouTube, if you're listening to it live, you're also being able to see some lovely images from our observing team. If you'd like more information or you're trying to navigate around the observatory, we always recommend you check out our website at www.yorku.ca/science/observatory. There are links for this particular broadcast, the OPV, as well as teletubes and tours and all kinds of things. This broadcast is powered by and in partnership with astronomy.fm, although they are not currently running tonight. They are still the voice of astronomy. If you have any questions or comments for past shows or suggestions for future topics, you can always send us an email at observe@yorku.ca. And of course, we're on Twitter, or X as it is now called, speaking of changes, at York Observatory or York Universe, actually. And Instagram, York U Observatory, Facebook at Allan Carswell Obs. And of course, if you're watching this on YouTube, you already know you can find us here too. So all of our programs are free, but if you'd like to make a donation, you can see that same website from before, yorku.ca/science/observatory. Our amazing crew is monitoring the chat room on YouTube for questions and here to post you interesting things about the beautiful pictures. The weather in Toronto has been hit and miss, a little bit like our broadcast, very, very dynamic in Toronto, although not as bad as some of the other places around Canada. So we'll go ahead and get this show on the road, as we say. A little bit of a different show for tonight. Julie, how are you doing with your weather up there?
It was cloudy today. I'm
Yes.
assuming it's still cloudy. But I'm not too worried about the weather. I'm just happy I had good weather last week.
Yeah, it's been hit and miss. We did get a night of remote-ish observing from some of our crew on Saturday, so I suppose it's about usual in terms of cloud content for this time of year. And we can hope that it will be getting better in the next few months, maybe even several clear nights in a row, if that's not too much to ask for.
I'm just back from my stint as astronomer in residence.
Yes, do tell.
So yes, so I had clear nights almost every night that I was
Well,
there. There was one cloudy night and a few clouds night. But other than that, it's beautiful.
and that was out of seven whole nights or six nights and
6
7 days.
nights.
6 nights and 7 days.
7 days. Yeah.
Yeah, the clear skies up at Killarney Provincial Park are pretty hard to beat, I have to say. And just as a reminder for anybody who doesn't know, you can find Julie's blog as well as our current astronomer in residence, Raj, his current blog, on that same website I keep telling everyone, the yorku.ca/science/observatory, and just go to astronomer in residence blog area. All the latest photos are there. And Julie, your photos are great, I have to say.
Oh, thank you. Yeah, it's not just photos of the sky. Actually, it's mostly photos of not the sky. It's mostly photos of a snake. Waffles.
Well, to be fair, the cell phones don't capture the sky with quite the same accuracy.
They don't. But I did take my first DSLR attached to the back of a telescope photograph while I was up there. So
That one is on there, isn't it?
it is on there.
Yeah.
It is the one astrophotograph that is in my blog.
I remember seeing, I mean, that's really good.
I thank you.
So
Nothing processed. It's just a 30-second exposure of the Ring Nebula. That was like, hooray, I succeeded at a thing. I did take a full run of photos the next night. No, not the next night, because the next night was the rainy night, but the night after. And now I just need to learn how to process things. So that's my next project.
data processing.
Yes.
Well, I keep telling everyone our website, but we do have free instructions for how to data process with Cyril that was actually put up just was it last year or a few months ago? One of our
cool.
wonderful co-op students wrote it up as they did it. And as you know, there's a lot of ways to process data in astronomy, but the free clickable sort of way is harder to come by. So I actually really recommend Cyril to anyone who's getting started. And that is also free on our website. So just saying.
Awesome. I will go over. What's that website again, Alana?
Oh gosh, well, thanks for asking, Julie. yorku.ca/science/observatory, and that's in the Observers Tools section. So lots of fun for everybody, and we're trying to put everything we could possibly need on there, and so far it seems to be going pretty well. All right, so we have a show to put on tonight, in addition to just talking about awesome astronomy stuff and wonderful skies. I think let's go ahead and do some This Week in Space and Astronomy History, traditional part of this show. Speaking of, I guess, skies and things that can go into them, let you go ahead and start us off, Julie.
All right, so we're going to start with August 25th, 1997. And the launch of the Advanced Composition Explorer, or ACE, or also known as Explorer 71. The spacecraft was developed by NASA Goddard and it was a mission to study energetic particles from, I guess it is a mission to study energetic particles from the solar wind and interplanetary medium and other sources. The real-time data from ACE are used by the National Oceanic and Atmospheric Administration, otherwise known as NOAA, by their Space Weather Prediction Center, SWPC, to improve forecasts and warnings of solar storms. The spacecraft is in a Lissajous orbit close to the L1 Lagrange point, which lies between the sun and the Earth. And anyone who's been paying attention to, space telescopes in the last couple of years has heard of a Lagrange point. It's still operational and in good condition and is projected to have enough propellant to maintain its orbit until next year. This spacecraft has a load of instruments on board. It has a cosmic ray isotope spectrometer. It has an electron, proton, and alpha particle monitor. It has a magnetometer, a real-time solar wind instrument, a solar energetic particle ionic charge analyzer, which sadly is no longer functioning as of 2008, but had a good decade there. The solar isotope spectrometer, the solar wind electron, proton, and alpha monitor instrument, the solar wind ion composition spectrometer, and the solar wind ion mass spectrometer, and the ultra low energy isotope spectrometer. So we're doing a lot of spectrometry here.
That is a lot of things.
It is a lot of things. This is the little satellite that could.
It's the Inspector Gadget satellite.
Yeah, pretty much. The science objectives were to investigate a wide range of fundamental problems in 4 major areas, those being elemental and isotopic composition of matter, the origin of the elements and subsequent evolutionary processing, the formation of the solar corona and accretion of solar wind, the acceleration of solar wind, that makes more sense, and particle acceleration and transport in nature. Some results include particles of various energies being observed over a span of a couple of solar cycles. And ACE data has led to a greater understanding of particle acceleration, the interactions of slower and faster moving particles in areas where they meet that cause shock waves, the acceleration of particles by interplanetary shocks, anomalous cosmic rays, and galactic cosmic rays.
Wow, that it really is an Inspector Gadget of telescopes.
Like a Swiss Army knife.
Yeah, it's just doing everything. Well, not everything, but it's doing an awful lot of things. And it's awesome. I was reading up on this a little bit, and it's interesting that so many of the different it's many different functions are, despite being, a little bit away at L1, in very, very good demand for Earth science, or at least orbital Earth atmospheric sort of science, because these things impacting our atmosphere, especially solar wind, and how much solar wind or what kinds of particles are coming in, that's going to affect our northern lights and our all kinds of different things around our local atmosphere.
Yeah, not to mention all those satellites we depend on for
those
all
there
that
are
other stuff.
all that other stuff. Well, I mean, GPS, I don't know, I don't think actually all that many satellites went into GPS, but there's an awful lot of things in orbit, which is its own issue. But of course, these particles can also interact with the ISS and any human crafts that are out there. Gosh, we just saw the Virgin Galactic launch, so they would have wanted to know what the weather was up there before they went in.
For sure. It's really neat to think about. Like, I think a lot of people, when they think about the solar system, you plunk the sun in the middle and there's the sun. It's there, it's in the middle, without thinking about like how much effect the sun and everything that comes off of it. Like, it's not just in the middle and there it stops. Like, all those particles just keep traveling outwards and having effect on everything.
Yeah, well, and it is, of course, one of the fun things in astronomy. You can try to picture the solar system, and sort of to scale, little grapefruit-sized sun with like little tiny, oh gosh, poppy seed or something for Earth, some some distance away. And it's like, yeah, it's putting out this incredible amount of energy, despite the fact that there's just this tremendous amount of empty space between us and everything else. We're still getting so much energy from the sun, so many interesting particles, so many interesting interactions. And of course, it's interacting with our magnetic field and Jupiter's magnetic field, and I don't know, probably not much of Mars's remnant magnetic field, but it's really cool stuff. And figuring out what to do about it and where to move your satellites so they don't get fried is a very practical application as well.
Oh, absolutely. Especially since we like our satellites.
Well, there's some more than others, I suppose.
Absolutely. Some more than others.
Some more than others.
Contend we don't need 10,000 satellites for one single network.
And yeah, it's having most of us have in astronomy having been Starlinked at one point or another. It's like we do appreciate the internet access, but this seems a bit excessive.
Yeah, there's got to be a more efficient way of doing this that doesn't break astronomy.
Well, speaking of not breaking astronomy, because well, actually, speaking of some of the interesting particles that you're seeing in ACE, these cosmic rays, and other things, being outside of Earth's atmosphere is absolutely vital. So I think I can use that to get to our next adventure here. And that was August 23rd, 1960. So this week in history, ish, 1960. This is one that you might not have heard of. It's a little bit of an interesting launch. An Aerobee, 150A. So, rocket aficionados, eat your heart out. If you know who designed the Arrow B, please put it in the YouTube chat and get some, I don't know, kudos. It's one of the ones I haven't heard a lot of. So sort of went down a rabbit hole looking at cosmic rays. And August 23rd, 1960, an Arrow B-150 sounding rocket with it instrumented with 44 BF3 proportional counters was launched from Wallops Island, Virginia. And this was a geomagnetically quiet day, which means that some of that weather that we were talking about in the first episode here, or first event, was not interacting with our magnetic field as much. There weren't as many solar particles coming in. So this is a geomagnetically quiet day, which is my definition of geomagnetic quiet, by the way. The rocket reached a maximum altitude of about 200 kilometers, so it wasn't extremely, extremely high. And the counters were looking at all kinds of interesting things. So they're looking at different types of isotopic enrichments, looking at counting rate due to neutrons and evaluation of the background rate of ionizing events, which were then compared with other types of measurements made at the time, usually from balloons. And this was looking at cosmic rays, because cosmic rays, believe it or not, they're not just noise on a CCD. It's actually quite important for all kinds of things. Cosmic ray neutrons up to 200 kilometers were viewed. And this was a measurement particularly of what were called slow cosmic ray neutrons. And this is a really interesting launch to me, not just because it was an evaluation of cosmic rays, which we're talking about, but it was done in 1960 when we really didn't know much about a lot, cosmic rays, X-rays, all these things that were outside of Earth's atmosphere, very hard to characterize. And it actually came about in a really interesting way. It came about from James Van Allen. So if you got that name in chat, I don't know, 10 astronomy points to you, because I didn't actually know about this until I started reading about the cosmic rays. And of course, a lot of us have heard of the Van Allen belts around Earth, the radiation belts, which were, of course, named for him. And one of the reasons why was he was involved in these rockets. He actually drew up specifications for the Arrow B sounding rocket, and he headed the committee that convinced the US government to produce it. So these Arrow B rockets were hugely important in advancing, in particular, cosmic ray research. How cool is that? So the first one was actually done in March 1948, and they had a lot of launches from various different places. White Sands, New Mexico was particularly popular, carrying instruments for cosmic ray research, and they wouldn't even go up so high. So the first launch, I think, was around 117.5 kilometers. The launch that we were talking about, measuring slow cosmic ray neutrons, that's up to 200 kilometers. And so drawing up these specifications for the Arrow B sounding rocket and being part of this kind of initial push into, I guess, rocket technology. And if you get a chance to look at pictures of the old Arrow B rockets, they absolutely do look like science fiction. They've got an extremely long, narrow nose, and they look like something somebody would draw for a science fiction book. So
Oh,
they're
yeah.
they're lovely, lovely devices. And the scientific research done with the Arrow B family of rockets was a lot of photography. So geographers, people who are interested in the ground studies, were really interested in that. But they also did some of the very first biomedical research and biology at high atmospheric conditions. They did study of energetic particles, ionospheric physics, all kinds of stuff. So a little bit like what you were saying with your ACE spacecraft, I should call it the right thing, spacecraft. Your ACE spacecraft, they kind of try to do as much as possible. And they were using these Arrow B rockets because they were a little bit easier to manage than the really, really, really big ones. It doesn't have to get all the way out to, for example, not to pick on anyone, Lagrange point number one. It just had to get a couple hundred kilometers off the ground. So Aerobees did all kinds of great stuff. They weren't just about cosmic rays. They did solar physics and spectrometry and infrared studies, magnetometry, ultraviolet, X-ray, all kinds of great stuff. And they were launching primarily from the US, but they actually did a really cool crossover program with Australia. And I was like, wait a minute. They also launched from Australia, almost 20 launches, so that they could cover both the northern and southern hemispheres, which is really cool. So Aerobee were actually a really, really big part of America's effort in, or especially the U.S. effort, I guess U.S. and Australia's effort in geophysics, and a lot of biomedical missions as well, although those probably are not so great to talk about because they did actually put mice and monkeys into them, which is not great. But Aerobees themselves did a lot of stuff in the 60s, and of
A
course,
lot
all
of heavy
being
lifting.
maybe not heavy, but
Aw.
a lot of lifting. That was one of the advantages, is because they were smaller and easier. At least my reading of it was that they were smaller and easier than a lot of other crafts of their time.
Yeah.
And of course, being literally designed by Van Allen of the Van Allen belts as part of this really interesting point in history. Well, I just had to put it in here because it might look like just a measurement of slow cosmic ray neutrons, but actually it's kind of a really interesting time in astronomy history.
That's cool. When you mentioned counters at the beginning, it reminded me of I was listening to No Such Thing as a Fish, and they talked about an election where they were using computers to do the bids or the ballots. And some like fringe candidate got more votes than was possible in the county or region. And after doing like all the investigation, they determined that what had happened, or what must have happened, was that a cosmic ray hit the transistor.
Yes.
And like flipped it from a 0 to a 1 and made it look like this candidate had like a bajillion votes when they had not.
And that's actually there have been some really interesting cases of cosmic rays interacting with electronics, and there's special shielding that they do now, but it's not a non-zero possibility that a cosmic ray could come in and cause an interaction in your computer, because your computer is just using electrons.
Yeah.
And if something comes in and generates a bunch of electrons, it could really mess up what your data actually says. That's a great example.
Yeah. And they were saying that as transistors become like use lower energy to flip on and off and become smaller and smaller, these interactions are going to become more and more frequent.
Yes. Well, and of course they're down to looking at limits in atomic size, because the miniaturization of transistors is what's driven computer power, and they're actually at the order of some computer components being so small that they have to worry about quantum tunneling and in the size of an individual atom. Which is just crazy when you then think about, well, there could also be cosmic rays coming in, and that would just, destroy everything you have. So big shield there, I guess.
That's pretty wild.
Anyways,
the world's best computer. We had to build it at the bottom of a mine to shield it from stuff.
Just put a couple optical CCDs. Those are really good at catching cosmic rays.
Awesome.
I always get tons on mine, all my images. No, but anyways, observatories are awesome and cosmic
Mhm.
rays are fun too. So I think you've got yet another interesting observatory that was actually launched all the way into space.
Yes. So this launch happened on August 21st, 1972, and it was the launch of the Orbiting Astronomical Observatory 3, which was also known as Copernicus. And the Orbiting Astronomical Observatory satellites were a series, of 4 satellites. They were launched by NASA between 1966 and 1972 and were managed by NASA Chief of Astronomy Nancy Grace Roman, who will soon have a telescope named after her, which is cool. The OAO series included the first successful space telescope, which was OAO2. OAO1 failed once in orbit, and provided the first high-quality observations of many objects in ultraviolet light. And the success of these space telescopes led to the instigation for the Hubble Space Telescope. AOA-3, or Copernicus, proved to be the most successful of the OAO missions. It was a collaboration between NASA and the United Kingdom's Science Research Council, which is currently known as the Science and Engineering Research Council. And it was not named Copernicus at launch, but it was renamed Copernicus after launch to mark the 500th anniversary of the birth of Nicholas Copernicus in 1473. It carried an X-ray detector built by University College London's Mullard Space Science Laboratory and an 80-centimeter UV telescope built by Princeton University under the supervision of Lyman Spitzer. And so this was NASA's first multi-wavelength astronomy observatory as well. And it operated until 1981. It returned high resolution spectra of hundreds of stars, along with extensive X-ray observations. It discovered several long period pulsars, such as X Persei, that had rotation times of many minutes rather than the more typical seconds or less, and confirmed that most of the hydrogen in interstellar gas clouds existed in molecular form.
Very cool.
Yeah.
And yet another multitasking. I mean, it makes sense though. If you're going to spend all the money to put it into space, it really is just doing everything it can. And I'm glad you mentioned X-ray.
Yes.
X-rays, of course, are really, really interesting in and of themselves. And until we could get out of the atmosphere, we had a lot of trouble characterizing what kind of X-rays could possibly be coming from outer space.
Yeah. Yeah. I like both of these wavelengths, right? You needed to get out of the
Yes.
atmosphere.
Yes.
I
Well,
also
I think
find
that
interest. Go ahead.
oh yeah. I think it's really interesting in particular that the X-rays come right after our other two stories where we were both looking at ways to view not just X-rays but also cosmic rays and these sort of high energy spectrum.
Yeah. The other thing I find interesting about this story is that we have Nancy Grace Roman, who will have a telescope named after her soon, and Spitzer, who already has had his telescope named after him. I think it's just like people involved in this project have gone on to have telescopes named after them.
For good reason, I think.
Oh, yes, absolutely.
I mean, in particular, the Nancy Grace Roman was, for a long time, at least, popularly not widely known. And I'm glad to see that is changing because she was hugely influential, of course, with Hubble and solar physics and all kinds of different things. And her work in this in the OA3 and OA2, I think she was involved with both of them, wasn't she?
Yeah, I think she was involved with the whole program.
Yeah.
Yeah.
Amazing person. Definitely worth reading up on.
Homework for
And
everyone out there in radio land.
oh yes, absolutely, absolutely. Well, optional homework. There's a lot of fun rabbit holes to dive down,
Oh yeah.
and of course the early X-ray work and Nancy Grace Roman and Hubble, and they're all really fun stuff.
Yeah.
I mean, X Persei itself, I think I could easily spend an extra couple hours on, but that's maybe for a different show.
Sure.
And it is I'll actually say it's quite fun getting to do this live on YouTube for one reason as well is that because we're live on YouTube, I actually do get to see some of the chats. And somebody did mention the Carrington event, which when we were talking about high energy interference, I suppose, that is probably one of the most popular. Maybe that and the 1981, was it 1980? Shoot, 1980, what was the Quebec power outage?
I want to say 89.
Yeah, that was another real famous one, but the Carrington one was way before that. That was 1859. And that was, obviously a very different time for humans because we did not have the amount of electric devices that we do now. And a lot of people have asked is what would happen if a geomagnetic storm like the Carrington event happened today? Like what kind of outages might occur? It's an interesting question to contemplate.
So yeah, 89 was the Quebec one. And actually, while I was preparing for my solar observing session that I did last week while I was at Killarney, I was looking up, I was like, when I know we're close to solar maximum, like let's get the exact date. And the article that I was reading was saying like how the sun's been super active this cycle. And that so much so that as much as like the prediction was saying how the maximum was expected for 2025, it may start later this year rather than 2025. And
which would make 2025, who knows how strong, right?
Who knows? Like the max will last a year to 2 years, depending on you kind of like the max happens and then you look back at the data and go, yes, that was the max.
Yeah, exactly.
But also like, because it's so active, the potential for disruptions because of solar storms is that much higher, and we are not prepared.
Well, and that's for a really truly large event, and we're not talking about maybe the 1980 Quebec event, but a Carrington level event. These extremely large solar storms, they can really affect things in ways that you wouldn't expect. And of course, the usual story that's given is that the telegraphs of the time were working without being connected. Because of the electromagnetic field.
That's awesome.
So
also spooky.
Yeah. So
if you don't know what's happening,
it literally created a current strong enough for telegraphs from the east to west coast to talk to each other. Maybe not all the way. How far over is Boston? No, but Boston to Portland was the telegraph for the Carrington event, and they actually said they were able to send messages without being connected due to the current in the air. I was like, what would that do to like a Tesla or like a cell phone? I don't know. I mean, I really don't know.
Fried.
Well, maybe some things would, but there's been a lot of developments in like how power stations are designed, especially after Quebec.
Yeah.
And there's a lot, I mean, we have Faraday cages. So a lot of really important stuff is in a Faraday cage, which is a protection against things like this. So it would depend
so
on
some infrastructure would be okay.
Yeah, some things would be okay, but it would
But I
be
feel
very
like a lot of
hard.
people's like devices might end up fried.
Yeah, I would tend to agree. I would think that a lot of devices would end up fried. But maybe if your car had a metal frame, it would be enough of a Faraday cage that would be fine. I don't know.
I don't know.
Something again for anybody who's looking for an interesting rabbit hole to hop down.
Or an interesting research project.
Yes,
We might
exactly.
just have given someone their thesis. You're welcome.
On that note, let's go ahead and remind everyone that you are, in fact, listening to York Universe. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Our website is yorku.ca/science/observatory for all the information about what's playing and, of course, anything that is going on during the week. We have chat happening right now in YouTube, and we, of course, are following along on Twitter at York Observatory and York Universe. And tonight you're listening to Dr. Elena Hyde and Julie Tomei, and we are discussing a high energy astronomy in many different forms. As a reminder, if you are navigating over here at a later time, you can always get to the YouTube OPV chat by going yorku.ca/science/observatory and then clicking on any bar for OPV or YouTube link, and that gets us to the YouTube OPV where we are tonight. We are not on astronomy.fm this evening, but we might be in the future if we get if we get this recording up to them. So we're just on YouTube tonight for York Universe. A little bit of an adventuresome mode. So let's go ahead and quickly cover a few little program updates. And well, actually, let's go ahead and do the last this week in history, and then we'll do the program updates, just to keep us in order. So we've talked about the Orbiting Astronomical Observatory 3, or Copernicus Orbiting Astronomical Observatory, OAO. Thanks to Julie, and I'm going to go in a little bit of the same direction, sort of following along, but with a little bit of a different topic. This is one that I just thought was kind of cool. In 1962, on the 18th of August, so a few days ago, this week in history, 1962, the very first, at least the first I could ever find records for, the very first auroral research rocket launched into the ionosphere from Norway. And I thought, this is fun. How many space launches have we heard of recently from Norway? And I think they've been neglected on this show, so it's about time that we covered them. So this is a little bit of the story of Ferdinand 1. And this was the rocket that was to take Norway into the space age. So this happened about 5 years after the Soviet Union at the time launched the first man-made satellite, so Sputnik 1. I believe that's a pretty famous quote you'll see from astronomers all over. Um, Beep, beep, beep. It's just getting things into space was somewhat of a new idea. The Norwegian scientists named the rocket Ferdinand, which is apparently after a story from a peaceful bull that didn't like to fight. So, sort of a peaceful intentions rocket. And it carried two instruments. So it was basically there to investigate and to look at auroral research. So we've talked about energetic particles interacting with all kinds of things. We've talked about cosmic rays. We've talked about solar storms, but just regular energetic particles from the sun interacting with our atmosphere do tend to cause aurora. And that's something in Canada we see up north. And of course, they have southern aurora as well down in Tasmania and New Zealand. And the Aurora research rocket was going into the ionosphere in order to investigate some of these ionizing particles and not only look at the northern lights, but also look at long-range radio communication. Of course, in 1962, radio was very important. So our astronomy.fm partners broadcast online, but radio waves traditionally are traveling through the atmosphere, and having a knowledge of the ionization in your atmosphere is very good. Free electrons will reflect radio waves. So if you're trying to do long-range radio, this would not be great. And if you're trying to improve your long-range radio, knowing about what kind of free electron reflection rate you might get would be probably pretty good. So this is a fun little project, I guess, a fun little rocket. It was launched from a place that I'm probably going to say a little bit wrong, but it's Andoya Rocket Range. I'm not sure exactly if I'm pronouncing that right, but it was actually the first of many successful rocket launches from Andoya. So if you haven't heard of the Andoya Rocket Range, go ahead and look them up. They've actually done quite a lot since then. So they have a few different launch sites around, but this particular one, the Ferdinand one, was there to basically investigate the northern lights, investigate, of course, ionization in the atmosphere for long-range radio communication, and look at measuring when charged particles from the sun ionize atoms in the ionosphere in particular. It's most intense in the polar ionosphere. That's where the magnetic field of Earth sort of funnels electrons up, because a magnetic field has a north and a south. An electron is a negatively charged particle. So they're going to want to collect at the poles and interact there, which is why we get the aurora on the northern southern poles ish, unless it's a really, really active time for the sun, in which case you can't even get aurora that are visible almost to Toronto. I haven't seen any in Toronto since I've been here, but if we got that Carrington event, I think we probably would see them quite widely. So just a little bit of fun history. The rocket that was launched, the Ferdinand 1, was only 7.7 meters long and had a total weight of 698 kilograms. It launched about 102 kilometers into the atmosphere. So again, not quite as far as you would need to get into space and be properly in orbit, but enough to be able to monitor the ionosphere. So a little bit of a fun rocket launch and a little bit of, I suppose, fun astronomy history.
That is so cool.
Yeah, I thought this would be.
I had no idea Norway had launch capabilities.
Yeah, and I guess their web. Sorry, make sure I said it right. The one that's hard to pronounce. The Andøya Rocket Range was actually just the first of several launch spots that they actually had in Norway, and they picked up around the time that, of course, Russia was launching and the US was launching, but they didn't get as much, I guess, press as some of the other folks. And in particular, I think in Canada and in the US, we tend to maybe not to give as many props as are due to places like Norway and other folks that have launched awesome things. And investigating aurora, or these, blasts of magnetically charged particles from the sun crashing into the magnetic fields of Earth, that's a pretty cool mission. And the fact that they, as far as I know, and again, please, you can tell us if we're wrong in chat, but I believe this was the first actual monitoring of aurora that was done with a rocket launch. So
that's cool.
And just a little note for folks who are maybe following along and haven't heard us talk a lot about the Earth's magnetic field before. Just like a bar magnet has a north and a south, the Earth's poles have a magnetic north and south, and it stretches out from the middle of our planet and sort of tucks back in at the opposite pole. So where the field lines bunch up is going to be towards the north and the south. And that's where the sort of the charged particles get funneled in, and we get interesting little aurora, what's called aurora ovals around the poles. And you can see this around other planets as well. Jupiter is very famous for having beautiful aurora, and it's near its poles. But
There's
yes,
also photos of the Earths from space.
yes, and the Earth from space, and gosh, what's another famous one? Venus has some caveats that we probably don't have time to get into, but Uranus and Neptune both have some interesting things as well, and Norway has more rocket launches than we had originally maybe given them credit for.
Awesome.
And their facility has launched for ESA, NASA, JAXA, and DLR. So,
note to self: learn more about Norway's space program.
Yeah, I know, right? Go Andoya, which I probably need to play that pronunciation one more time for myself later. All right, so let's go ahead and do some space reminders for everyone. Aurora research, that's the end of our This Week in Space and Astronomy history. I think we've rounded off a nice set of interesting cosmic ray, high energy aurora causing space things. Now, I have a little bit of a fun reminder for everyone. We have a few events this week. So we have a special guest speaker, Teletube, coming up this Wednesday. So this York Universe being on YouTube has a special advantage. If you're watching this live on YouTube, you're already in the right spot to come back on Wednesday, 7:30 p.m. Eastern Time, and catch our special guest speaker who's going to be talking about entropic gravity, which is really interesting topic that we don't get nearly enough of, I think. So that will be happening this coming Wednesday, August 23rd. So this is Monday the 21st for all of our listeners who are also having a Monday. Our next announcement is that we have, of course, a new astronomer in residence who has recently arrived on site. Raj Sierra, who is coming back actually for the second time. So he was with us last year as well, and should be posting some interesting stuff to his blog soon. So maybe some more star pictures. But whatever it is, I'm sure he's got better weather than we do here in Toronto. So it'll be worth following along. And he'll be there for 7 days, which is I think about the usual amount of time that people go for their astronomer in residence tenure. So good luck to Raj, and you can follow along with his blog on that same website we just keep telling you over and over again. So lots of fun stuff happening this week. And of course, next week, I believe we're back up with a tour. So that's all the reminders that I had for everybody. I hope that most folks did get to view some of the recent meteor shower, the Perseids. They're fading out pretty badly, so I don't think you're going to have much luck seeing anything by this point. Next try is in about a month and a half, I think, for the next meteor shower. Were you able to see any Perseids, Julie?
No, it was cloudy.
Clouds. Yeah, I tried to look once or twice, and I did get to see a few, but I wasn't able to catch the peak. So if anyone's got some peak Perseid pictures they'd like to send us.
Yeah, I probably caught a few while I was up at Killarney, but it was already a couple of days past peak, so like literally one or two.
Yeah, and they kept saying it would be 100 per hour at peak, but I don't actually know anyone who got that number. And most people I talked to was like, oh, we saw a few, and it was nice.
I saw a few clouds. I got a sucker hole, but I did not see any meteors.
Those are the worst
in that sucker hole.
All right. So
well.
next up we have some news though.
Yes.
We've got some news, and I think we've both got some pretty good stories. So
Yeah.
we're gonna go from high energy to moon
Yeah.
topics.
We're going from the sun to the moon.
From the sun to the moon. And Julie, why don't you go ahead and start us off with this first one, because this is really cool.
Yeah. So we're starting to get some results from the Chang'e 4 mission, which was the Chinese mission that landed on the far side of the moon back in 2018. And it's been taking photos and sampling minerals from the moon's mantle. The U-2 rover is equipped with lunar penetrating radar, and that allows scientists to see the structures in the upper 1,000 feet or 300 meters of the moon's surface. And so new data were published by Jian Ching Fang, and apologies if I have mangled the pronunciation of their name, who is an astrogeological researcher at the Planetary Science Institute in Tucson, Arizona. Fang is the lead author on the paper, and the data suggests that the top 130 feet of the lunar surface is made up of multiple layers of dust and soil, broken rocks, but hidden under that is a crater that was formed when a large object slammed into the moon. And Fang and his colleagues hypothesized that the rubble surrounding this formation was ejecta, so debris from the impact. And then further down, they discovered 5 distinct layers of lunar lava that seeped across the landscape billions of years ago. So after the moon formed, it continued to be bombarded by objects from space for roughly 200 million years. And some of those impacts were powerful enough that they cracked the surface, allowing magma to seep through. And the Chang'e 4 data show that process slowing down over time because the layers of volcanic rock grew thinner the closer they were to the moon's surface, suggesting that less lava flowed in later eruptions compared to earlier ones.
Wow, that's quite the lunar adventure there going on. Astrogeological structures. I think, when you say structures in the moon, it immediately evokes, images from everything from Lovecraft to I don't know, Space Odyssey. But this is actually a really, really practical and valuable result, because what the lunar surface is made of is going to make such a big difference for what we can put on top of it and how we're going to be able to use it.
Yeah.
If humans are going to set up a base on the moon. And of course, that's still a little bit of an if. But there's some big hopes by a lot of folks that we will actually be able to set up a lunar gateway and start putting things on the moon to make it more of a permanently habitable, perhaps even. But what's on the surface is going to determine whether or not we can build with lunar soil, because of course the astronauts came back and were like, that dust is not to be messed with.
Yeah. We'd still have to get to it.
Yes.
And deal with the dust that's not to be messed with. But certainly, there are uses for basaltic rock.
Oh yeah, and if you know where the basaltic rock is and the lava rock is, I would imagine that would help you quite a lot with your building projects.
For sure.
And speaking of building projects, We have some other moon news that I'm going to try to squish in here right at the end. So not just the surface, but also, of course, the lunar South Pole has been a huge deal recently. So mapping structures and knowing what kind of rocks are where is one project. Knowing where the water is has been another project, mostly, well, I mean, large thanks to Chandrayaan-1, who went out there and did an amazing job looking at the lunar water in some in hidden craters or permanently hidden craters on the moon. Now, recently, this has been a little bit of I don't know, a mini space race that sort of stopped very, very, very quickly the other day. Russia and India were both trying to send crafts to the lunar South Pole, and it was a little bit of little bit of tension, a little bit of space race. It was Russia's first lunar mission in 47 years, and they crashed. So it's now been on the news that officially, yes, they are done. Russia has crashed out, but Chandrayaan-3. Chandrayaan-3 lander is actually still on its way. So Indian sort of space officials have, I think, from what I've seen, mostly downplayed any competition, but there was, I think, a bit of a space race there. And of course, China and the US both have lunar ambitions. The lunar South Pole as a location that definitely is known to have an incredibly valuable resource of water is kind of a hot, I mean, maybe not hot, a cold, super cool topic. So it's a very desirable place to go. And Russia having recently crashed, everyone is now watching to see, will Chandrayaan-3 make it to the South Pole? And so the news is, of course, that Chandrayaan-3 is still on its way. It's entered its sort of the pre-landing sort of initial approach, and it seems to be, at least at my last reading shortly before this broadcast, it seems to be still on track. And if it does get there first, and land successfully and is able to send data back, it will be able to tell us about that water ice that they have already found on the moon. And is it accessible? Is it mineable? Is it extractable? Is it something that we can use on the moon? And if so, this might make, I mean, and again, this is several ifs in a chain here, might make the South Pole of the moon a very, very popular spot for everybody from Artemis through every space agency that says they're interested in the South Pole. So, a lot of these missions have been planned for years and years. And of course, Chandrayaan-3 is happening. Chandrayaan-2, unfortunately, did not work out particularly well. But a lot of it is the same, has a similar idea, is to get into the moon and get to that South Polar region and have a look at and what kind of water is down there, because of course no humans have ever walked down there before.
Please tell me we're not going to start fighting over the South Pole again.
I don't think anyone's fighting yet. It's going to require people to be there first, I think. So.
I feel like if instead of racing to places, we work together to get there, be more efficient.
And that actually is a lot of the messaging that I've at least heard out of the Indian Space Agency, and the Russian Space Agency might have been racing, but they did crash, so they're not there anymore. So it's kind of like, okay, well, the people who are going seem to be quite interested in the science, and that's always nice because, of course, when you're sharing your scientific data, people can work together to solve problems. And the moon is a giant puzzle. There's so much we still don't know about the moon. We have some pieces, we have some edges, we have some lunar meteorites, we have a couple samples of soil, but yeah, there's a lot that we don't know, and especially that South Polar region. So, it's going to be up to India and Chandrayaan-3 to make the next attempt. And of course, we're also looking at what's going to happen with the Artemis program next year. Is it still planned for next year?
I don't know. I'll look it
And
up.
yeah, and I would keep waiting for someone to say it's going to be delayed. But a lot of the interesting things with this water on the moon is what kind of water would it be? Is it going to be processable? If it's early solar system water, we can't expect that to be the same kind of water that we would find on Earth because our water is obviously super weird and has been processed by all kinds of organisms. um, and so, you get these interesting craters that are without illumination. Um, it's just a fascinating area, and of course, the latest news is Chandrayaan-3. We're crossing our fingers for you. I hope they make it.
Yes.
All right. Well, on that note, it's probably about time to wrap up for the evening. Everyone, thank you very much for joining us on this slightly irregular broadcast over on our YouTube channel. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Julie Tomei and myself, Dr. Elena Hyde. Stay tuned if you're on astronomy.fm because we hope to be back there soon, but we don't know when. You can always find us here or on astronomy.fm on Monday nights. And you can always connect with us on Twitter at the handle York Universe or York U Observatory, and Facebook, Allan Carswell Obs, as well as Instagram, of course, York U Observatory. For any show notes, content updates, contact info, and all kinds of fun tools, as well as astronomer in residence info, go to yorku.ca/science/observatory. Thanks for tuning in to York Universe.